Welcome to Ask and Learn.
Right, for this problem, let me see. We know the amount of gas, we know the initial temperature and the pressure, and we also know the volume of the cylinder. So we know the amount of heat. Okay, so for part A, uh, says if the volume of the cylinder is constant, so we want to find the temperature of the air. Uh, because uh, because because the volume is fixed, so the work is zero. In that case, Q equal to delta U equal to N times CV times delta T. Okay. And N is given here, 0.185 moles. CV for the air is simply equal to 5/2 times R. So, and Q is 645 joules. So we can obtain that delta T equal to 167.7 Kelvin. Sorry. So T final equal to the T initial. T initial is here. T initial plus the delta T. So the T final is 947.7 Kelvin. And PV diagram is so this is P, this is V. PV diagram, we just need to keep the V as constant. So it's just a vertical line. It goes up. And for part B, so the pressure is constant. In that case, we can use a simple way. Just Q equal to N times Cp times delta T. All right. And Cp in this case, it's 7/2 times R. So basically, Cp just equal to Cv plus R. Okay. And we can also find out the delta T equal to 119.8 Kelvin. So we obtain Tf equal to the initial temperature plus this delta T equal to 899.8 Kelvin. And this is the PV diagram. P, V, it's just a simply horizontal line. Just in this direction. Okay. Yeah.